Okay, let's look at an AP question of the day dealing with continuity. This question says, on which interval is the graph of f of x is equal to 2 over the square root of x minus 1 not continuous? So no calculators. You can't reference your calculator. You need to think about what we were talking about, where the square root function is defined, and then see what you think. So pause the video, think about it for a second, and then come back to the video for my explanation. So where's the graph not continuous? Let's start with where it is continuous. All right, so we've got a couple of issues here. First of all, we've got a rational expression because it's a fraction with a variable in the denominator. Second problem, we've got a square root as well. So let's deal with the square root first. It's the square root, so x minus 1 has to be greater than, I am messing that up. X minus 1 has to be greater than or equal to 0. Because we can take the square root of 0, but not anything less than 0, because that would be a negative number. So that says x has to be greater than or equal to 1. Well, then we've got to consider one more thing. It's in the denominator, so it can't actually equal 0. So really we're just looking at x is greater than 1 is our domain. That's where it's defined. That's the domain and continuous. But it's asking where is it not continuous. So let's look at our intervals really quickly. From 2 to infinity, we're okay there. 2 to infinity is included in x is greater than 1. That one's okay. B, from 1, not including 1, the parentheses means not included, the bracket means including. So from 1 to infinity, we're good. That's its domain, that's where it's continuous. C includes 1. Well, if we plug 1 into our equation, we get 2 over the square root of 1 minus 1. That is the square root of 0, which is 2 over 0. That's undefined. So I'm thinking C is not good, but let's check D just to be sure. D is from 1 to 2. Well, 1 to 2 is included in x is greater than 1. So that one's okay. It is, in fact, not continuous on the interval, including 1 to infinity. All right, so here are the problems that you need to work on. In the textbook, you'll find the attachment. Let me show you a couple of examples that are like number 63, 65, and 66, because I can see there may be being some issues. So that section asks you to take this piecewise function. I'm using number 64 for an example. Take the piecewise function and figure out, well, what value of a would make this function continuous? What value of a would make the function continuous? So let's think about this for a second. This changes at 0. Okay, this function changes at 0. So to the left of 0, it looks like this function, 4 sine of x over x. To the right of 0, it looks like a minus 2x. Well, we've got to figure out, well, how can we make those pieces match? So we need to know the y value of this first piece. At 0, what's its y value? So I can figure out what the y value of the second piece needs to be. So if we plug in 0, oh wait, here's that lovely function again. Sine of x over x. This is not good. This gives us 0 over 0. Well, let's use what we know about sine of x over x. Forget the 4 for a second. Sine of x over x, at 0, we know it's getting really, really, really close to 1. So really, we're going to look at this and we're going to say, okay, well, that's 1. So we've got 4 times 1. So the y value here is 4, or needs to be 4. There is a hole. There's a hole there, but that's where it would be. Okay, so that means that a minus 2x equals 4, at x equals 0. So we plug in 0 for x. So that says, well, a needs to be 4. If a equals 4, those two pieces are going to match. You can check that. Use your calculator, okay? Type in 4 sine of x over x and type in 4 minus 2x and see if they intersect at 0. Look and see if they intersect when x equals 0. Their y value should be 4. Okay, let's look at another one. Let's look at number 66. Okay, number 66 is one of those piecewise functions where we've got the equal to and the not equal to. That should be saying in your head, when you see the equal to and the not equal to, you should be thinking, this is a piecewise function that has a hole. This is a piecewise function that has a hole. So we have a rational function for the first piece, and we've got 8 for the second piece. Looking at that first piece, I'm thinking that simplifies. That should simplify. So let's factor that. X plus a times x minus a over x minus a. Cancel the x minus a's. So we get x plus a. And let's see here. That's when it's not equal to a. So let's just sketch that out real quick, okay? Let's say this is a right here. So everywhere but at a, it looks like this. Okay, everywhere but at a, it's looking like this line, x plus a. I don't know what a is, so I don't know where to put my y-intercept, but I'm just kind of guesstimating. It's got to be the same thing right here, okay? But this is supposed to be continuous. So this other part says that when x equals a, the y value is 8. So it's supposed to plug that hole. So the y value is 8 when x equals a. So let's take this equation, x plus a, it's got to equal 8 at x equals a. So plug in a for your x. 2a equals 8, that says a equals 4 again. That says a equals 4 again. And you can check that as well. Plug in 4 for a right here into your equation right here and see if that doesn't have a y value of 8. Okay? When x equals 4. All right. One other thing that's important as we move along, we need to review, learn, if you haven't learned this before, that the absolute value function can be viewed as a piecewise function. The absolute value function can be viewed as a piecewise function. And you'll need to know this for evaluating limits without a calculator. So let's go through the steps of turning the absolute value function into a piecewise function. So let's just start with the absolute value of x. All right, let's just graph that. All right, you should know that it looks like a V and it touches the origin. Mine's a little off center there, but it touches the origin. Now, piecewise function, you're thinking left side, right side. Look at the left side of this. It looks like a line with a negative slope. Look at the right side. It looks like a line with a positive slope. Well, it turns out that if we want to write this as a piecewise function, I always do it in this order. I always do the left side first. So for the left side, you change the sign in front of the absolute value, and you drop the absolute value bars. And that's when x is less than 0. Because I know it changes at 0. You take what's inside your absolute value and you set it equal to 0. That's where it changes. The right side, you just drop the absolute value bars. So you've got x. And that's when x is greater than or equal to 0. Now, it really doesn't matter where you put the equal to. Technically, you can put the equal to with the less than. It really doesn't matter because these are always continuous. So it doesn't matter which piece gets the equal to because they have the same y value at 0. They have the same y value. Now, they're not going to ask you to just deal with the absolute value of x. So let's look at a little bit more complicated example. Let's look at this. Negative 2 times the absolute value of negative 2x minus 6 minus 1. Now, the first thing I need to show you right here, when your variable has a negative coefficient inside the absolute value, you've got to start by factoring out that value. That changes the sign right there. Okay, you've got to start by factoring out a negative 2. And the absolute value of negative 2 is positive 2, so that gives us a negative 4 on the outside. Okay, that gives us a negative 4 on the outside of our absolute value, because the absolute value of our negative 2 right here, okay, this negative 2, the absolute value of that is positive 2, and positive 2 times the negative 2 out here gives us the negative 4. Okay, it stays negative because the absolute value of negative 2 is positive 2. So this is the function we're going to be dealing with. All right, so we've got to figure out where it changes. We take what's inside the absolute value, set it equal to 0, and solve. So this one's changing at negative 3. Now, we would have gotten the same thing if we had solved this original part, okay, for the changing point. Now, it's going to mess things up otherwise if we didn't fix it. You got to fix it first. Okay, so I always do it in the same order. I change the sign of what's in front of the absolute value, so it becomes positive 4. My absolute value bars become parentheses, and I'm going to distribute and combine like terms. So we get 4x plus 12 minus 1. My left side is 4x plus 11. Then I leave everything the same. I just drop the absolute value bars and distribute and combine like terms. So negative 4x minus 12 minus 1. Negative 4x minus 13. So here's my piecewise function. G of x equals 4x plus 11 when x is less than negative 3. Negative 4x minus 13 when x is greater than or equal to negative 3. Now, if you don't believe me that changing all that stuff and distributing will give you this absolute value function, then graph it. Okay, then graph it. So I'm going to type in my absolute value. Got to know where the absolute value button is here. I'm going to type in the original. Whoops, make sure I close my parentheses right there. Minus 1. And then I'm going to type in my two equations. Now, the problem with this is it's going to graph more than I need it to graph, but it would be obvious if it was not correct. Okay, so there's my absolute value function. There's my first line. There's my second line. If you ignore the stuff on the top, because the top right part is going beyond what we need. That first line that was graphed was supposed to be the left side, so it's supposed to stop at negative 3. The top left part, I wasn't supposed to start graphing that second line until I got to negative 3. So those top two lines are not there. I overlapped with my absolute value function down there. All right, but you've got to know how to do this by hand, because they will ask you limits involving absolute value functions without a calculator, so you've got to know how to be able to turn them into piecewise functions to be able to evaluate them. Okay.